In lecture, we've been discussing how one can determine the empirical and molecular formula of an unknown compound by simply determining the mass of each element in that compound. So today we're going to do an experiment where we determine the empirical formula of magnesium oxide. And like we learned in lecture, in order to do that, we need a sample of magnesium oxide in which we can measure the number of grams of magnesium and the number of grams of oxygen in that sample. There's two ways one could approach that. We could take a sample of magnesium oxide and then chemically break it apart into magnesium and oxygen, but that is extremely difficult. Magnesium oxide is a very stable compound. It is difficult to break it apart. So we're going to take the opposite approach. We're going to start out instead with a piece of magnesium, and we'll be able to weigh that, so we have our grams of magnesium, and then we're going to burn this magnesium in air and convert it to magnesium oxide. So as it burns, of course, oxygen is going to be combining with the magnesium, and the mass is going to increase, and that increase in the mass will be our grams of oxygen. So at the end of the experiment, when we weigh the grams of magnesium oxide, we can simply subtract our initial mass of magnesium, and that will give us our grams of oxygen. So we have our grams of magnesium, grams of oxygen, and just like we learned in class, we can convert those into moles, get a mole ratio, and that will provide us with the empirical formula. Now we're going to be burning our magnesium in one of these ceramic crucibles. These crucibles are designed to take a lot of heat, and we're going to be heating it over a very hot Bunsen burner flame because magnesium ribbon is a bit difficult to ignite. Once it starts burning, it really burns, but it takes quite a bit of energy to get it started. The magnesium ribbon, of course, needs to fit in that crucible, so we're going to take our piece of magnesium ribbon and sort of crumple it up into a loose ball. It needs to be small enough to fit into the crucible, but we want to leave room for air to move around in between the pieces so it burns completely. So we can put our magnesium, it fits in there very nicely. We'll go ahead and burn that and then treat the product as it specifies in the lab procedure, and at the end we'll be able to weigh the magnesium oxide product. Be sure and watch the pre-lab video that follows this, which will go through the theory and give you some hints on how to answer the questions at the end of the lab. Then we'll head on over into the lab, carry out the experiment, and then you can record the data and complete the lab. In today's experiment, we're going to be determining the empirical formula of magnesium oxide. It's the same kind of problems that we did back in Chapter 9, where you measured the mass of elements and then converted those to moles and finally a mole ratio. But in this experiment, instead of me giving you the values, you're going to be measuring them in the laboratory. So the basic reaction we're going to be carrying out is to combine magnesium with oxygen in the air to form magnesium oxide. And your job is to figure out what the subscripts are, X and Y. Now hopefully you could figure that out on your own by simply looking at the periodic table. You should be able to do that, but today we're going to do it experimentally. We want to measure the mass of magnesium and the mass of oxygen in a sample of magnesium oxide, and then use those masses. We'll convert them to moles, and then figure out our mole ratio. So our source of magnesium will be a piece of magnesium ribbon. We've already pre-cut those for you guys so that they fall within a mass of 0.5 to 0.75 grams. That happens to be a fairly convenient amount. Oxygen, of course, we just get out of the air. So we'll be using oxygen in the air to combine with the magnesium, and then that will be converted into magnesium oxide. You'll be recording your information in the table in the lab. You won't need to do a trial 2 as long as trial 1 works out. And of course, since I'm going to be providing you with information today, since we're doing this online, I can promise you trial 1 will indeed work. We'll be carrying out the reaction in one of our crucibles and covers. So the first thing we'll need to do is to rinse off the crucible and cover with deionized water to get any material, any dirt out of there, and then dry it over the Bunsen burner flame for a couple of minutes to make it dry, and then we can simply record the mass of the crucible and cover into our first blank in the table, which is M1, the mass of the empty crucible and cover. So in this case, our crucible and cover weighed 27.21 grams. The next step is to add our piece of magnesium ribbon to the clean, dry crucible. First, we'll want to make sure we wipe off the magnesium ribbon with some steel wool, because magnesium tends to oxidize in the air and it gets coated with some magnesium oxide, and that can throw off your final results. So we're going to clean that off, and then we'll weigh the crucible and the cover and the magnesium, and that will be M2 in the table. Now we're going to go ahead and burn the magnesium. So we're going to heat the magnesium. It's going to catch on fire, and I've got some videos that I made in the lab, and I'll be showing you those in just a couple of minutes. But we're going to burn the magnesium ribbon and convert it theoretically into magnesium oxide, and then we can weigh the crucible and cover in magnesium oxide in the end to figure out how much oxygen was actually combined with the magnesium. But there's a problem. Magnesium is a very reactive element. Very few things will react with nitrogen, because nitrogen is very unreactive, but magnesium is one of those things. And because the atmosphere is 78% nitrogen, you're going to get magnesium combining with nitrogen to form a different product, which is magnesium nitride. Now, this isn't going to weigh the same as magnesium oxide, so that could be a real problem. But fortunately, there is a simple solution to that. What we're going to do is add some water. So once you've finished burning the magnesium and the oxygen, let the crucible cool off, and we'll add 10 drops of deionized water to the crucible. Any magnesium nitride that's present will immediately be converted to magnesium oxide, and at the same time it will produce a byproduct of ammonia. If you take a whiff of the crucible after adding the water, you'll notice that telltale smell of ammonia. Now, because we've added water to it, the magnesium oxide is wet and there's extra mass from the water, so we'll want to bake the crucible dry, and once it cools off, we can then get our final mass. So here we have our crucible and cover with our dry magnesium oxide, and we can simply weigh that and record that value, and that gives us our final mass. You guys can use these numbers to complete the rest of the table. The mass of magnesium is just M2 minus M1. The oxygen is M3 minus M2. And then using what we learned back in Chapter 9, you can change the mass of magnesium oxide and oxygen into moles of magnesium and oxygen, and then get a mole ratio, and from that figure out the empirical formula of the substance. There are 2 pages of questions at the end of the experiment, and those on the first page are a little complicated. They're going to take a bit of thought on your part, so I'm going to give you a little bit of guidance here on how to approach each of those 4 questions. All 4 of these have one thing in common. They're each asking that if a particular error were made during the experiment, how would the results be affected? And where students often lose points in this lab is they're not specific enough. I say, how would the results be affected? The student will say, it would be different. It would be wrong. That's not really what I'm looking for. I want to know exactly. Each of these 4 different errors or problems that can arise in the lab are going to change the masses that you measure at the end of the lab. those masses are what give us the amount of magnesium and oxygen that allow us to calculate the empirical formula. So for each one of these, I want you to ask yourself, how is that going to change my final mass? Every one of these is going to cause that final mass of magnesium oxide to either be higher or lower than it should be. If the error makes the final mass higher than it should be, it's going to seem like you have more oxygen than you really do. If the error were to make the mass lower than it should be, then it will make the oxygen appear to be less than it should be. So each of these errors is going to shift that magnesium to oxygen ratio. So basically in each of these four, make sure when you answer it that you're specific, that you tell me, okay, this particular thing would have increased the amount of oxygen and made the ratio of oxygen to magnesium greater than it should be, or vice versa. So to get full credit on these points, just make sure you're thorough. You know, it's not a problem giving me too much information. It is a problem if you give me too little. In this pre-lab, I gave you some hypothetical values for M1, M2, and M3. And it would be good practice for you to go ahead and go through those calculations and come up with the empirical formula for magnesium oxide. Now we're going to go over into the lab and get some real-life data. I'm going to run the experiment, and I'll let you record the information here for trial 2 and see what we come up with actual experimental data. Normally, the first thing we would do is to wash and dry the crucible and cover, but because this is a brand new one, that's not actually necessary. We can go ahead and weigh them directly. So go ahead and record the mass of the crucible and cover. Now it doesn't say to do this in the lab, but I sometimes find it useful to weigh the crucible cover by itself, because sometimes in the course of the lab, if you drop it and break it, then you no longer have that mass. So if we go ahead and weigh it separately, if that does happen, we can simply add that mass to it at the end. So let's go ahead and get the mass of the cover itself and just write that down in the lab book somewhere in case we need it. Now we need to measure the mass of the magnesium ribbon. Magnesium tends to oxidize in air, and it can be coated with a layer of magnesium oxide. So the first thing we'll need to do is to clean it off with some steel wool to make sure we have nothing but pure magnesium. Now we can go ahead and return our crucible and cover to the balance. And then before we can place the magnesium in the crucible, we're going to need to crumple it up into a loose ball, like I showed you during the pre-lab introduction. So you want to wad this up until it fits in the crucible, but still leave it open enough so that air can get in, because we need to make sure we thoroughly burn the magnesium ribbon. That looks like it's going to fit very nicely, so simply record the mass of the crucible and the cover and the magnesium. Now let's go ahead and light up the Bunsen burner. We'll turn on the gas and go ahead and get it lit. Now we want a real hot flame to ignite that magnesium, so we'll open up the air valve to get a nice hot blue flame. And then it's going to take a couple of minutes at least before the magnesium ignites, so we'll pause now and then we'll come back once it's ignited. It looks like the magnesium's getting close to igniting, so we'll take our crucible tongs and push it down. Getting the metal closer to the crucible tends to make it ignite faster. All right, let's try that again. Now, if the magnesium doesn't ignite very readily, I have a little trick I sometimes use. I will take the Bunsen burner and put the flame just briefly right on the magnesium ribbon, and that usually will ignite it very quickly. And there we go. Now it's burning quite nicely. The key thing now is we want to make sure that if there's a lot of smoke, it doesn't escape. So we'll be ready to put our crucible cover on if need be. That smoke is the magnesium oxide product, and we don't want to lose that. But it appears that it's burning fairly gently this time, so we probably won't need to cover it up. So we're going to have to heat this for several minutes now. Why don't we go ahead and zoom in a little bit and get a closer look. We'll get a little more of a close-up now. You can see the magnesium still burning gently. All the little flashes there show that it's igniting. We can help that by stirring it around a little bit with our glass stirring rod. We want to make sure all of it burns. As long as there's still red light coming off of there, that tells us there's still magnesium to be burned. I'm going to burn that until it's just a dull gray powder. We'll go ahead and stir it around a little bit more here. There we go. We can angle it a bit so you get a little better view there. There we go. I think we're getting closer now. Once it looks like it's pretty much completely burned, we'll go ahead and heat it for an additional 5 minutes just to make sure. So let's go ahead and do that 5-minute heating now. We've been heating it now for 5 minutes. And there's no more flashes of light, and it looks like a dull gray powder, so it appears that we're done. So we can go ahead and turn off the Bunsen burner now, and we'll let it cool for about 5 minutes. And then once it's cooled, that next step will be to add water to convert any of the magnesium nitride into magnesium oxide. As I mentioned in the pre-lab, magnesium not only reacts with oxygen in the air to form magnesium oxide, but it also reacts with nitrogen in the air to form magnesium nitride. The problem is magnesium nitride doesn't have the same molar mass as magnesium oxide, and therefore our final product is not going to weigh what it should. Fortunately, there is a fairly easy remedy for this problem. If one adds water to magnesium nitride, it very quickly is converted to magnesium oxide. So we're going to add 10 drops of deionized water to our magnesium oxide. Now, to make sure that the water reacts completely with the magnesium nitride, we're going to cover the crucible, and then we will light the Bunsen burner and heat the magnesium oxide and the water gently for about a minute or so, and that will allow the water to sort of percolate around inside the crucible until it's completely converted any magnesium nitride we have into magnesium oxide. We'll let this go for about a minute or so, and then we will remove the cover and heat it more vigorously to remove any remaining water so that we can get the final mass of our magnesium oxide. We've been heating the crucible now for about 1 minute. So all of the magnesium nitride should have been converted to magnesium oxide by now. So we'll turn up the flame and heat the crucible for several minutes until all of the water has been removed, and then we'll be able to go ahead and get a final mass of our magnesium oxide. The crucible's been heating now for several minutes, so all of the water should be evaporated by now. So we just need to turn off the burner and let the crucible cool down. The crucible is cool enough now that we can go ahead and get our final mass. So this will give us the mass of the crucible and the cover and the magnesium oxide. You should have all the information you need now to go ahead and determine the empirical formula of magnesium oxide and then answer all the questions at the end of the lab.